Okay, welcome Chanel and Joy and Taylor, and hopefully there'll be others that join us also. This is week 7. We're past the halfway point. So there's a lot going on right now because next week, what big thing is happening next week? Yeah, the midterm is happening. And if you haven't already, and a lot of you haven't already, you must give me the information on where you're going to be taking your midterm. I made it a quiz, so it's easier to just type that in, and then I'll be able to send you the midterm. I plan on doing that tomorrow and Thursday to send out the midterm. I actually already sent one out today because the person needed it. They needed the midterm sent before the proctor would say yes, which was kind of interesting. So I did. So anyway, I have written the midterm. It's all ready. The plan today is we will go over hypothesis testing, which is chapter 8, or chapter 8. Is it chapter 8? No, chapter 9. I'm sorry. I always blank on which chapter is which. Chapter 9, hypothesis testing for a single population proportion or a single population mean. And this turns out to be probably the most important chapter because in terms of using stuff, because we're going to spend the rest of the entire quarter on hypothesis testing. So it's really important you do everything you can to understand hypothesis testing this week, because the longer you wait to understand it, the more lost you'll be, which is no fun. So it's much better to understand it now so that you can get it. And I'll talk about that today. Of course, there's always a book, and there's a long video. There's the homework and the discussion post. There's lots of different ways of studying hypothesis testing. I'm also, after that, talking about the midterm. We have the midterm again on Wednesday, and tomorrow your midterm information quiz is due. And what I do is that if you don't get it to me by tomorrow, then I take off at least 5% deduction off the midterm. So there's no reason to procrastinate. You need to get that done. And I'm happy to help you if you need help, but the clock is ticking. So you definitely have to get that in. Again, a bunch of you have done that, but there's still a group that still have to send it to me. So are there any questions about anything before we start going? Any questions? Okay, if there's no questions, what I'm going to do is we're going to talk about hypothesis testing. Hypothesis testing, again, is probably, it's really what the rest of the entire course is all about. Every single week, we are going to be doing hypothesis testing. So today, we're doing the two simplest types of hypothesis testing, and that is a single population proportion and a single population mean. And we're going to be looking at those. And hypothesis testing is when you have to make a decision. You have to say, yeah, I'm ready to go with it because I have evidence, or no, I'm not ready to go with it. Whereas last week we did confidence interval, and that wasn't about making decisions. That was just about making an estimate and saying, well, I think it's about here, but I might be off by this much. And that's what confidence intervals were about. So now we're going to get into, again, hypothesis testing. So let me do it by example. And I have an example. It's kind of interesting. I have one that I've written a long time ago, but it's actually big in the news now. So I figured I might as well use that as kind of a current event, even though it's not that current. Okay, so let's go ahead, and I'm going to share my desktop. And I have a question for you in a second. Okay, so here's the question. Oops, I got an extra in there, but that's all right. I wonder how that happened. I should say, in the United States, 1.5% of children are autistic. A researcher wants to see if this percent is higher for children who are vaccinated. Okay, this has been big in the news. There's all these people that are the anti-vaxxers. And then, I don't know if you've read, but what happens if you don't get vaccinated is you get the horrible diseases that people get vaccinated for. And that happened recently with the measles, I believe it was. So suppose that 5,000 vaccinated children tested, 77 of them were autistic. Usually 5% level of significance. Okay, so this is your typical question, is that we have this idea, and the idea is, well, maybe people who are vaccinated have a higher percent chance of being autistic. And the idea is you want to test the hypothesis to find out whether or not there's evidence for that or not. And that's really what hypothesis testing is all about, is collecting data to see if there's evidence to back up a claim. And the claim here, again, is that you have a higher percent rate of autism for those who are vaccinated. Any questions on the idea? Any questions on the idea? Okay, so you have seen this before. Some of you a very long time ago, some more recently. What this is called, that you've heard of before, is a scientific method. Y'all heard that before? Okay, and you remember from 8th grade when you dealt with it and had to go through each of the steps of it? Because that's when you first get it, is around 8th grade, as you talk about the scientific method. Okay, yeah, it's been a long time. So we're going to go over it, but we're going to go over it, instead of thinking of it as a science class, now we're going to be doing it as a statistics class. But it's really the same process, except that we're going to have calculations to do the scientific method instead of just, I don't know, run some experiments. We're actually going to be doing statistics. Shouldn't be surprised about that. So that's the plan. So when you do hypothesis testing, the first thing you do, and I have an ABC, there's more that comes, but I'm going to need space, so I only put ABC now, and I'll put more later. Is the first thing is you got to state the null and alternative hypotheses. So the null hypothesis, that is kind of what the other guys are saying, the status quo. So in this case, the null hypothesis is vaccination doesn't do anything, right? We're checking to see if vaccination is going to make it a higher percent than what it was. So if vaccination has no effect, then it should still be 1.5%. Now notice, and this is really important for this entire quarter now, is that the first question you always ask yourself in all these problems is, what kind of survey question was it? Okay, so what is a survey question? Can someone type in or tell me what the survey question is? Open this up. So if you're the researcher, what are you going to write as your survey question? Okay, it's a percentage. Okay, so that's a good idea. That's not the survey question. It's not the, is the percentage higher for children who are vaccinated. That is actually what we want to decide is true or not. It's not what we're going to ask the individual people. We're not going to ask this child, is the percentage higher for children who are vaccinated? What are you going to ask this child? It's a good try. It's not, have you been vaccinated? Actually, our population is all the people who have been vaccinated. And we want to find out if we got more than 1.5% autism. Any thoughts? Can I jump in? Yeah, are you autistic? Because that's the question. We want to find out what percentage of people are autistic of those who have been vaccinated. So are you autistic is a survey question. And notice that this is a yes or no question. Is that clear? Either you are or you aren't. Okay, we're just going to go that way. We're going to have a level at which we're going to call autistic. So in particular, since we have a yes or no question, we're talking about proportions and not means. Any questions on that? Okay, so because of that, let me state the null hypothesis. And the alternative hypothesis. Let me do it this way. So what you write down is H naught. Okay, so not actually is a word in British English, and it means 0. So if you didn't know that, that's what it is, and the British got to it before the Americans, so we got to use not. Okay, so H naught, notice the next symbol after that 0 is a colon. It's not an equal sign. So don't make the mistake because you don't want to lose points on the midterm. So H naught, since we're talking about proportions, what letter do you use for proportions? P. Okay, actually lowercase p. I think you wrote capital P, but I'm going to let it go. Okay, so we're going to use a lowercase p, and the idea is the null hypothesis is kind of the status quo. If nothing's changed, if everything is as it used to be and there's been no effect, then what should the proportion be? Looking for a number here. Yeah, 1.5%, but we need to change that to a decimal. Yeah, 0.015. So don't forget, you got to move the decimal over 2 places, and you get 0.015. Any questions so far? Okay, then I want to state my alternative hypothesis. So the alternative hypothesis I write as an H1. Okay, some people use an HA instead of an H1, A for alternative. But our book and also the calculator uses H1, so I'm going to use H1. And that is going to be P. And now we got to find out what the inequality is. So the null hypothesis is a status quo. If there's no change, everything is as you know, it doesn't mean anything to be vaccinated or not, then it should be 0.015. Although, what are we trying to show or check to see? What inequality are we looking at? And there's a key word there. So what inequality are we looking for? Any thoughts? It's in the words. Yeah, greater than. And the key word is higher. Do y'all see that word higher? So P is greater than 0.015. Any questions so far? Okay, and by the way, there's a very, very strict ordering at which you do hypothesis testing. Very first thing you have to do is state the null and alternative hypotheses. Basically, that is kind of what you want to test. Okay, you do that before anything else. Then what you do is part B, which is discuss the ramifications of a type 1 and type 2 error. So first thing, I need to define these things because you probably don't know what a type 1 error is. So let me write down what it is. Maybe I'll do that in purple. So type 1 error means that you reject H naught when H naught is true. So that's what it means to be a type 1 error. Okay, what does it mean? What does the word ramifications mean? I know there's always a few people that don't know that word. What is ramifications? What is that word? Yeah, consequences. I like to think about it as the damage done and who gets hurt and how that pain, what kind of pain is going to happen, what kind of damage will happen due to this error. Remember, errors are never good. Okay, so the question is what damage will be done if we have a type 1 error? So what damage will be done if we reject H naught when H naught is true? And when you reject H naught, that means you're going to accept H1. So if we're going to accept H1, what does that mean we've decided is true? So if we accept H1, what must be true? Okay, greater than 0.015, and it means, yeah, it's autism. Vaccinations are, that means vaccinations cause higher rate of autism, okay, or at least there's a higher rate of autism among vaccinated children. Does that make sense? So that means we're going to accept that fact, but in fact, it's not true. There isn't a higher rate of autism. Would that be bad? Yeah, and what damage will be done? What are the consequences of accepting vaccination causes higher rates of autism when it doesn't? Yeah, kids won't get vaccinated, and what's the consequence of that? Hopefully y'all know. Yeah, disease and death. Okay, that's pretty severe, by the way. Okay, hopefully you know you don't want that. So let's write that down. Okay, so that means that we will decide that vaccinations cause autism. Okay, and fewer people get vaccinated. Thus, many will die of horrible diseases. Any questions on that? Okay, so pretty horrible. Okay, now let's talk about a type 2 error. Let's change the color for that one. How about green? So let's do a type 2 error. Type 2 error is very similar, except it's kind of backwards. Instead of reject H naught when H naught is true, we fail to reject H naught when H naught is false. All right, so now let's take a look at that. What damage will be done if we fail to reject H naught, okay, when H naught is false? Any thoughts? Yeah, it means that we're going to vaccinate kids, and you're going to end up with a lot more kids having autism, which would be a bad thing. So notice these errors are both bad. Okay, so what we would do is, I guess I can write this way, we won't be able to determine that vaccination causes autism when it does. And what will happen is people will still get vaccinated and they'll get autism. Okay, and that's bad too. So notice type 1 and type 2 errors are both bad. One is you have, thousands of children dying of diseases that they didn't have to die of. And the other is you have thousands of children who get autism when they didn't need to get autism. Okay, they're both bad errors. Do y'all agree? Okay, if you don't think the errors are bad, you're probably doing it wrong. Just let you know. Errors are always bad in hypothesis testing. All right, so now what we want to look at, the next one's kind of easy, is a sample size large enough to conduct the hypothesis test. Explain numerically. So let's take a look. First thing, what is the sample size? Sample size is 5,000. Does that make sense, Joy? Because there were 5,000 vaccinated children tested. Okay, so remember that you test when you have a yes-no question. This is very important. It's not about being over 30. It's about NP and NQ being greater than 5. Okay, in this case, P is 1.5%. When you're doing hypothesis tests, the P corresponds to what this number is, what the what's in your H naught, P equals 0.015. So if you look at 0.015 times 5,000, what do you get? Okay, what do you get? 75 by any chance? If I did my head right. And then, by the way, if you take 1 minus P times 5,000, that's 0.985 times 5,000. That is equal to 4,925 if I did my head right. What's important about those two numbers? What's important about 75 and 4925? They're big, but what does big mean? What do they have to be bigger than? What's our cutoff value? Not 30. Be careful. Next week I'll zap you if you do 30 with a yes/no question. With the proportions question, what's the cutoff number? Remember? Okay, that came from a couple chapters ago, by the way. Not 65. Okay, so they're both bigger than 5. So that means that we're actually able to use the hypothesis test. So we can use the normal distribution for the hypothesis test. Any questions so far? Do you remember that from the central limit theorem? You have to have NP and NQ greater than 5. So that was really important a couple chapters ago. Okay, I told you there's going to be some more questions. But I don't have enough space on the board, so I need to erase a piece of the board. Everyone okay with it? And then I'll pop in the next piece. All right, so let me erase it. Let me go select. And let's get to the next piece. Gotta move some stuff around. All right, so now what we're going to do is we're going to find the p-value. Okay, what the p-value means is the probability of getting a value as extreme as what we've got if H naught was true. So in particular, let's just draw a little picture. Whenever I say draw a picture, you should always expect the same picture. There's my good old picture, normal distribution. We have 0.015. And what we got was 77 over 5,000. Okay, 77 over 5,000 is what? 154.05. Sorry, not 15. That should be 51. Whoops. Let me look at that. Let me fix that. Select. One more try. Apologize for that. Zero, 1, 5. Yeah, I got 0.0154 also. And that's a little bigger. 0.0154. Any questions on that? So then, as you're used to, I hope, we want to find that area. And that area will be the p-value. Any questions on that? And what we're going to do is if that area is very small, then we're going to say that it's too rare to occur naturally. So therefore, we're going to say the null hypothesis is wrong and the alternative hypothesis is correct. If the area is big, we're going to say, well, that happens normally. So there's no reason to think that the 0.015 is not the mean, or the proportion, I mean. By big, do you mean over 5%? Yeah, so over 5%. How do I find 0.0154? Oh, that was just 77 over 5,000. I did that in my head, sorry. Okay, so now we're not going to really have to do what I just did, the calculation, but I want to show you the picture because it's what we've learned. And this is really what's going on, but the calculator is going to do everything for us. So now what I'm going to do is I'm going to share my calculator, and let's play around with that. Go to new share, calculator. So I'm going to go to the stat button. And again, if you have your calculator, I recommend following along. And then I'm going to go to tests. Okay, unlike last week when we did the intervals, now we're actually doing real tests. So the test we're going to use is the one prop z-test. So one, because we have one sample and just one population. Prop, because it's a yes or no question, so we're looking at proportions. Z, because we have a large enough sample size. And test, because we're doing a hypothesis test. I'm going to hit enter. Now it asks for all the stuff. That P naught, that's going to be the P in the H naught, which was 0.015. The X, that is going to be 77 because our sample, 77, had autism. The N was 5,000. And here, we have a choice between not equal to, less than, or greater than. If you remember, our hypothesis had a greater than. That was H1. P was greater than 0.015. So I enter on that. You probably don't have this, and I don't care about the color. And then I hit enter on calculate. Any questions so far? Okay, just a couple notes. See where it says z equals 0.23? That's called the test statistic. Z means the normal distribution number for standard normal, and it's 0.23 about. The p-value is what says p. So p is 0.408. P hat was our sample proportion, which was 0.0154. That one we kind of did already. And n we know was 5,000. Any questions on that? Okay, so 0.408. Let's take a look at that. I'm going to reshare and go back to the question. So first thing, our p-value. I'm going to write p-value. There's so many p's in this class, it's good to write value. P-value was equal to 0.408. Now, notice that that's a pretty big probability. If something had a 40% chance and happened, would you be shocked? No, not at all. Okay, you wouldn't. If someone won a game and they only had a 40% chance of winning, would you accuse them of cheating? No, you probably wouldn't, right? If they had a 1% chance, you're going to worry that it might be cheating. Does that make sense? And what you want to think about is the game is the H naught. That's the other player. That's your adversary. And what you want to do is you want to win the game and saying, no, I'm sorry, H naught, you are wrong. H1 is right. Okay? Well, if there's a 40%, if there's a 40.8% chance of H naught winning and wins, you're not going to accuse H naught of cheating. You're not going to say you're wrong. You're going to say, oh, well, that happens. That's too bad. Does that make sense? Okay, our cutoff for when we're going to decide that we're going to accuse H naught of being wrong is 5%, because it says in the question, use a 5% level of significance. You see that? Now we got 41% about. So notice that 41% is certainly much bigger than 5%. Any questions on this idea? So we're not going to be able to say that H naught was wrong. So what we say is we fail to reject. So let me write that down. Now it's time to state our conclusion. Is the 5% the normal because it is statistically significant? Yeah, you know, what you didn't realize is that that whole statistical significance, that was all subliminal messaging for today. You didn't really know what it meant. Now you know what it means. So what you said is right, but it's kind of backwards. Yeah, so I've been using it just like I used the 30 on your project, and then you found out 30 was important, right? So the 5% I've been using all along, so you can get used to the 5%. Now, most people use 5%. Sometimes you can use less or more. Okay? It really depends on the ramifications of a type 1 or type 2 error. So that 5% is the probability of a type 1 error. If a type 1 error is really, really bad, then you probably don't want to have a high percent chance of that. And you might want to use 1% instead of 5%. If a type 2 error is really, really bad, then you probably want to go up and use a 10% chance, because it's a trade-off. You can say like nuclear war, but I'm going to go for like a million children getting measles. Okay, because that's what we're in now. So right now, not vaccinating your child, that's a big error. Okay, and if you're an anti-vaxxer, you need to read statistics. And you need to get it. Because, by the way, these numbers are pretty realistic. Okay, all the tests show that the vaccination shots don't change anything in terms of long-term health consequences in terms of autism. Okay, so these numbers are pretty real, by the way. Okay, I made them simpler. It wasn't quite 5,000. It was a messier number. I wanted to use easier numbers so we can do it in our head. But basically, this is what they found. Okay, so basically we have no evidence whatsoever. 41% is even in the ballpark of 5%. So what we say, now it's time to state the conclusion. And what we're going to say is that, whoops, I got to hit the T first. One more time. There is statistically significant evidence. Yeah, I'm sorry, Chanel. I'm sorry that you have to deal with the fact that your nieces and nephews might die of some horrible disease when they don't need to. Okay, it's not arguments, it's statistics. Okay, and you could look up the research. The sample sizes are much larger, actually. Again, I made it 5,000, but it's more like 100,000. Okay, there's statistically, sorry, not significant, insignificant evidence. To support the claim. More than 1.5% of all vaccinated children will get autism. Okay, notice this is a lot of kind of fancy words. Let me tell you what this is really saying. What it really says is that we did all this testing and we just weren't able to make the conclusion that vaccinated children have a higher than 1.5% chance of autism. In other words, you can't say they do, you can't say they don't, we just can't say anything. Okay, and when you can't say anything, that's when you don't take action. Does that make sense? You take action when you can say something. Okay, there are ways of going the other way, but I'm not going to go there because it's advanced statistics and not elementary statistics. But what we're doing is, in our class, you never, ever, ever accept H0. You never say it's exactly 1.5%, because remember, exact probabilities are impossible when it's continuous distributions. So you just don't go there. You just do fancy language to say that we weren't able to make a conclusion. Any questions on part A? Okay, now let's do, or the new part A, sorry. Let's do part B, the new part B. Interpret the p-value in the context of the study. So again, the p-value is this area over here, this area to the right of 0.0154. So we want to interpret that area. That area is a probability, because that's how you do normal distributions. Areas are probabilities. So let's interpret it. So the first thing we did when we drew this picture is I put 0.015 right in the middle, which means we're assuming, we're saying if the population proportion is 0.015. We started right there, right? Otherwise I couldn't even draw in this picture. So let's go ahead and do part B. And that is if 1.5% of all vaccinated children get autism, and if another study was done of 5,000 vaccinated children. Okay, so notice that we're saying let's assume we did one more group of 5,000, and then what the p-value is a probability that we'll get at least 1.54%, because that's what we got. That's what this area is. The area is that 1.54%. Okay, it's to the right of 1.0154. So then there would be a 1.54% chance, actually not chance, and there would be a p-value was 40.8% chance. That at least 1.54%, and that means, by the way, 77 of those 5,000 children would have autism. Any questions on that? So what we're saying is that in general, if H naught is true, and we conducted another study with that same sample size, then the p-value is the probability that we would get something as big or bigger than what we got. Okay, and by the way, if the null hypothesis had been a less than instead of a greater than, we would say as smaller or smaller. And if it had been a not equal to instead of a greater than, we would say as far from the center as what we got or farther, or as different from or more different than what we got. Any questions at all on interpreting the p-value? Okay. It's not that much calculator work. No, it's not that much calculator work, but you're going to get writer's cramp because there's a lot of writing. Okay, now we're supposed to interpret the level of significance. And let me tell you something. I'm going to copy and paste this first part because it's the same start. Hopefully it worked. Now let's interpret the level of significance. And what we're going to do is I'm just going to start the same. If 1.5% of all vaccinated children get autism, and if another study was done of 5,000 vaccinated children, then there would be a. Notice nothing changed. So you always start with if the null hypothesis is true, and you did another study with the same sample size, then now let's look at a probability. Now, if we're looking at the level of significance, it's 5%. That was our level of significance. Chance that the new study would lead us to falsely conclude that more than 1.5% of all children, all vaccinated children, get autism. Any questions on this? Okay. And I'm hearing some of you know people, and unfortunately the relatives that don't understand it. I could tell you that just have them look at statistics, except that most of these people don't understand statistics. Okay, I can pretty much guarantee that there isn't a statistician alive that is an anti-vaxxer. Because we understand. And hopefully people in my class will understand too. Again, look at the data. The data is really clear. Okay, any questions at all on this? Okay, you hear about one baby, it's a sample size of 1. And what do we know about sample sizes of 1 and making conclusions? Yeah, never do it. Okay, you better have a large sample size. 5,000 is good. Okay, for the vaccination thing, they've got like hundreds of thousands now. Any questions at all on this example? Okay, let's do another example. Next one will be different. Let me get this, and let me go down in size a bit. That's probably good. Okay, so what I need to do, is it okay if I erase this? Okay, gone. Okay. Yeah, the good news is it's recorded, Tammy. So if you got here late, you can still look at the beginning and rewatch it. Okay. So let's do another one. And if you've been to Lake Tahoe, or if you live in Lake Tahoe especially, then you know for us, the most important thing when it comes to taking data is our lake. We do not want our lake to get like kind of murky. We love our blue lake. And one of the things that could make the lake murky is what's called turbidity. So again, I don't expect you to understand the science, but this is something that is done. And actually, I partake in the data collection, not as a statistician, but as a volunteer community person every year. It's usually towards the end of May. It's a lot of fun. We go and collect samples. And then in a few of the years, I've actually been the statistician for it. I just volunteered. And I did the statistics so that they could try to understand how the lake is doing. So here's an example. The average morning turbidity in Lake Tahoe is 0.4 NTUs. A study of summer afternoon lake turbidity in Lake Tahoe was measured at randomly selected days and locations to see if the turbidity is higher in the summer afternoons. And the results are shown below. So here's a bunch of results. Okay. And basically, we're going to do the same thing. Okay. So we're going to do the same thing. We're going to see if it's true or not. We got to state the null and alternative hypotheses, get the p-value, get the conclusion, interpret the level of significance. I didn't write p-value, but we can do that if we want to also. And do we need to assume the distribution of turbidity in Lake Tahoe is normally distributed in order to trust the calculations? Explain. All right, so now let's go ahead and write down our null and alternative hypotheses. And I'm going to do this with brushwork. All right, so the first thing is the null hypothesis. Again, the symbol you always write is H naught. And then you write a colon. And then we look at this. How does this differ from the last example? There's a significant difference here. Not a sample. I could tell you sample size. It's what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we do have a sample size. Okay. There's something really different about it. And it's the next symbol I'm about to write. What's the survey question? What's a survey question? Okay, not is turbidity higher. That is the question of the study. It's not the survey question. What is the survey question? Okay, the survey question is, yeah, how many NTUs, right? The scientist just, did the study, grabbed a sample, and what you can ask that scientist is, How many NTUs are there in that sample? And then the first scientist is going to say 0.55. Is that clear? Okay, and because of that, it's quantitative. And when it's quantitative, we don't have P's, we have Mu's. Which is why I'm now doing it in a pen, because you can't type a mu. Any questions on that? So we're going to have a mu equals, and then 0.40. Any questions at all on H naught? Okay, H1 is going to be mu. This is another one with higher. Again, sometimes you see higher, sometimes you'll see different from, and then sometimes you will see less than. Yes, quantitative rather than a proportion, exactly. And that's why we're using mu and not P. Oops. I just made a mistake there. Let's fix that a little bit. One more try. Okay, so now we're going to have a mu is greater than 0.4. Any questions on that? All right, now we got to calculate the p-value. So let's go ahead. I got to do a reshare because we need our calculator. And trust me, you need your calculator for the p-value, especially on this type. So I'm going to go to stat, enter, because I got to put the data in, and go up to L1 and clear that guy out. And then I'm going to type the numbers in, 0.55, 0.42, 0.38, 0.91, 0.74, 0.88, 0.27, 0.56, 0.71, 0.41, then 0.47, 0.33, 0.68, 0.49, 0.55, 0.46, and 0.60. Any questions so far? Okay, then I'm going to hit stat again. I'm going to go to tests. And this time it's going to be a t-test. Okay, t because we're going to use the t-distribution because we have quantitative data. We have no idea the population standard deviation. So we use a t, and test because we're doing a hypothesis test. Then I hit enter. I have data. So enter on data. The mu naught was 0.4. Hit enter. List was L1. Freq is 1 always. We have a greater than mu naught. And I hit calculate. Okay, the test statistic now is a t statistic, and its t is 3.479 or so. So Tammy, you need to go to data and click enter on data first. That's why it's saying it's asking for X bar and SX. Just go to, if you click enter on data, then it'll give you all the things that I was looking at. Okay, the p-value is 0.0015. Okay, and that's the most important number. I often ask for the test statistic. You got to write that down. The p-value is the one we're really going to interpret, though. So 0.0015. Better write that down. So let us go ahead and reshare and go back to Paint. Okay, so now what we can say, let's write this down. So the p-value was equal to 0.0015. And we're comparing that with the level of significance. Notice, I don't think I gave you level of significance, but it doesn't matter because this is minuscule tiny. So often you just say it's less than 0.01 because that's as small as anyone ever goes anyway. Any questions so far? So now we're ready to make our conclusion. Notice this one's different because this one has a small p-value instead of a large p-value. Does that make sense? So there's a small p-value, and when you have a small p-value, that means that it's a rarely rare event. So again, if your opponent is playing a game and something happens that has a less than 1% chance of occurring, you're going to say, hey, wait a minute, I don't believe you. What do you think? Okay, whereas there's a 40% chance, you can say, yeah, that happens. Okay, but at such a small percent chance, you're going to say, forget it. I'm going to say that you're wrong and I'm right. Does that make sense? So the way we write it out is the following. This is going to be start the end of part B. There is statistically significant evidence to support the claim that the population mean turbidity in Lake Tahoe is higher in the summer afternoons. Okay, and if you want, even better is higher than 0.4 NTs. Any questions at all on the conclusion? Just like confidence interval, this is the important part. The others that I put in, those are less important. I'll test you occasionally, but this one's always going to be on every hypothesis test question. So you definitely need to be able to give the punchline. If you can't get the punchline, then you're wasting your time. Okay, the other bits are just kind of elaborating on what it might mean. So I'm going to interpret the level of significance. Okay, so maybe let's use a 1% level of significance because I wrote 0.01. And let's go ahead and do that. Okay, it's kind of similar to the proportions one. So if the population mean turbidity in Lake Tahoe is equal to 0.40 NTU in the summer afternoons. And if we conducted another sample, or we get, I guess, tested another sample, of sample size. And our sample size, again, was 17, I guess. Then there would be a 5% chance, sorry, 1% chance that we would end up falsely concluding that the mean turbidity in Lake Tahoe is greater than 0.40 NTU in the summer afternoons. Any questions on this? Yeah, what's your question?
It's faster to say it than to type it. Sorry. So in the one above it, it says that it is significant evidence to support the claim that it's higher than 4.0, but then on the second one, you said there's a 1% chance we would end up falsely concluding that it's greater.
Right. So these are different things. Okay. So the first paragraph is what the conclusion is. Our conclusion is we have statistically significant evidence to say it's greater.
Okay.
The other is, what does it mean to have a 1% level of significance? Before you even start the study.
Oh, I see. I see what you're saying.
Right? Before you even collect the data, that second paragraph can be stated. And in fact, you usually want to talk about it before you collect the data because you want to say, are we okay with a 1% chance of blowing it? Do you see that?
Yes, I do.
Because this is a percent chance of blowing it. If the mean turbidity is 0.4, we've blown it and we ended up concluding it's greater than, and that's bad. Do you see that?
Yes.
And are we okay with having a 1% chance of making that mistake?
I understand. Thank you very much.
Right. Which is very different than the conclusion. The conclusion is we were able to have statistically significant evidence, which doesn't mean it's 100% correct that we know for sure, but we have evidence, statistically significant evidence. Okay? If it's a life or death situation, then you probably need a bigger sample size because 1% is not good enough. Do you see that? So that's important to think about. Now this one's not a life or death situation, but the vaccination one is. Does that make sense? Okay. I mean, it sucks to have a cloudy lake, but it's not as bad as having 1 million dead children. Okay. Any other questions on this? I want to mention something because, again, we only have so much time in these webinars. First, the long video has more examples. And this is going to be on the test next week. Not lake turbidity and that, but the test is going to include hypothesis testing in a big way because that's a week's material. So you do need to understand this stuff, and you want to practice it, a lot this week. So that's something to note. I didn't go through every single possible outcome that could happen. In fact, I only did a greater than. I could have done a less than. And, be careful. If it's less than, of course, you're going to have, instead of in this paragraph where it says higher than, you'll have lower than. Okay. If it had been a different than, then you would say different from. Okay, those are the 3 choices. And notice in your calculator it gives you 3 choices. Less than, greater than, not equal to. Okay, so that's, again, I wasn't able to do every example because I can't. It would take many hours to do every possible example. But I gave you a few. Okay, and hopefully you get the idea of hypothesis testing, and then with lots of practice, you'll get good at it. So what I want to do is I want to talk about the exam. I think before that, since I'm on Paint right now, this is a good time to go through and give you the secret word. about that color? Make it kind of big. And the secret word of the day is evidence. So notice that in the conclusion, there is statistically significant evidence. So that's an important word for this week. Okay, and even in the last one, there was statistically insignificant evidence. So evidence is the word I chose for the week. Okay, any questions about anything I've talked about today before I go on to chat a little bit about your midterm? Okay, let me do a new share. Actually, before I do that, let's go. Oops. Just 1 minute. Always takes a bit to do the new share. One more try. Okay, now I'll do the new share. Okay, so this is our class. And, please ask questions as we go through this because I'm going to talk about the midterm now. So the first thing is I want to mention, which I've already mentioned once, but I want to re-mention it because it's coming up tomorrow. Okay, some of you have already done it, which is even better. And that is if you go in this week's module, you will see midterm information. Okay, notice it's not due the 24th, it's due the 20th, it's due tomorrow. Because last minute is a very bad idea for the midterm. Okay, it doesn't work. I need to get that midterm out to your proctor. So this means I got some days to do it. In fact, someone's taking it on this Friday. You're able to do that. But most people don't take it tomorrow. They take it at least by Friday or later. Okay, it'll look like this for you. And I just ask you a few questions. What day you can take it? What's the proctor's name and organization? What's the proctor's email? What's the proctor's webpage? Okay, not a lot of questions. Okay, but that is something that you need to do, you must do. And if you don't do it, let me show you what it says in the syllabus to remind you. Talked about it on the orientation, but I want to remind you again. Bad grammar, sorry. Students who complete this quiz late will receive a 5% deduction on their exam score. Okay. What do I mean by the web page? So for example, if you're using a public library, the link to that library. If you're using a college, the link to the college. What I do is I research to make sure that it really is a proctor. And that way I can go and check to make sure that person who you've sent the email on actually works there. Does that make sense? So I do a little research so that everyone has a real proctor. Does that make sense, Joy? Hopefully it's okay. So again, that's just the web page of the organization that is proctoring your test. Most of you are doing it at libraries and colleges, and they all have web pages. Okay, pretty much nowadays, anyone that does proctoring has a web page. Yeah, just the website of the college is fine, and I can find it from there. It just reminds you that, hey, this needs to be an official place. That's all. In other words, it can't be your best friend. Yeah, the test center has their own webpage. That's even better. But if you give me a place where I can find it, that's good enough too. Okay, so anyway, I wanted to show you that. So this has to be done by tomorrow. Tomorrow and Thursday, I'm going to be sending out all the tests. Okay, all but one, because one I sent today because the person needed it before they would do the scheduling. Okay. And I know one person's taking it Friday. That's coming. That's going to be the first one to get put in. Okay, now it's time to talk about the test. So let me go to the syllabus again, and let's look at something. Okay, so for the exam, here's what you bring. Okay, you bring a calculator, pen or pencil, and paper to the proctored exam. A single, and paper means blank paper. And some people don't need blank paper, but some people write big, and then it's easier to have blank paper, and then they can scan that in and send it to me. And you get a 3x5 single note card that you can have writing on both sides. Okay? I don't require that you memorize formulas, but you better have the formulas written on your note card that you don't want to have to memorize. Does that make sense? Okay, so that's what you get. The test is 2 hours. So when you go to your proctor, make sure that you set it up for 2 hours. Okay? If it takes you a little less, that's okay, but I still recommend spending the whole 2 hours and checking your work when you're done. Okay? So it's a 2-hour test, and you know, if I made it 5 hours, it could get really expensive if they charge by the hour. So that's why I keep it at 2. 2's about right. Okay? Some people have to rush through, and some people have plenty of time. It's really hard for me because everyone works at different speeds. So I do my best, and most people say that they're able to finish it. When I look at the test, I usually see writing on every problem. Strong recommendation, make sure you do have writing on every problem. Okay. We'll get to the questions about the particulars of the exam in a bit. Okay. So I'm seeing lots of good questions, and I'll get to that in a moment. Okay, but I just wanted to first give you the rules. I also wanted to show you, let's see if I can do it this way. Just a minute. Got to move some things. I think it was that one. Okay, let me get that one over here. Okay. So this is Katie. Remember I told you there's one person that I already sent it to? So this is what I send them. This is what I send them. It says, Dear College of the Canyons Proctoring Service. Of course, I'll be typing in whatever your proctoring is. Katie Connies will be taking the statistics midterm with you. I've attached the exam. Here are the rules for the exam. Okay, number 1, please check the student's ID to verify that the student is indeed Carrie Connies. So you need to have a picture ID. It could be your college ID, it could be your driver's license, but you need to have it could be your passport. You need to have some ID that has a picture that shows you are who you are. Okay? The student may bring pencils, pens, any calculator, not a smartphone or a computer with a calculator on it. A 3x5 note card with writing on both sides, blank scratch paper. Again, this is what your proctor is going to have. The student may not bring a cell phone, a smartwatch, notes other than what the student has put on the 3x5 note card, or any book. The student has 2 hours to complete the exam, and then the rest is business stuff on how to get me the exam. So any questions at all on kind of the logistics of the exam? Yeah, that's you, Katie. So yours got sent already. I told you it got sent. Okay, so any questions? All right, so now let me show you some resources because you guys are asking and about the exam. And I've done some things that hopefully that'll help you. I think I want to start out. I'm going to go to week 8 because that's the exam. And I think this one right here where it says midterm 201 W19 online shell ... X. That is probably going to be the most helpful for you. And that should answer all of your questions. Okay, or at least a lot of them. All right, let me go there. That might be too big. Let's try again. Okay, hopefully it's not too small for you to see. Sorry about that. Okay, what I've done is I took your exam And I erase the stuff I don't want you to see, but I left the stuff I do want you to see. Yeah, I call it a shell. If you want to call it a study guide, that's fine. I call it a shell because literally this is your exam with pieces erased. Does that make sense? So this answers questions like, how long is it? Because there it is. Literally, this is your exam. Okay. So you'll notice I don't have all the information. So for example, problem 3 is please circle the following true or false. And then it says A through I. I'm not going to tell you what they say, but I'm going to tell you there's an A, B, C, D, E, F, G, H, and I, a lot of them. Okay? Problem 4 is just some question from chapter 5. Problem 5 is a question from chapter 4. Problem 6 is a question from chapter 2. Problem 7, it says information given. That means there's going to be some paragraph that I'm not telling you. And then like part A is what assumptions must be made in order to compute a 95% confidence interval. Explain numerically. B is find the 95% confidence interval, write a complete sentence to interpret your results. C is use the sample standard deviation as an estimate for the population standard deviation. At least how many customers must you observe to construct a XX% confidence interval with a margin of error no more than plus or minus XX. Okay? So what I've done is I have given you the kind of all the things you need to study. Does that make sense? Yeah, it'll look exactly like this, except a couple differences, which, again, it doesn't matter for your studying. After part A, there's going to be a bunch of space for you to write it in. Does that make sense? So it's a lot more pages. I think this is what, there's 2 pages, and I think it's 10 pages or something like that. So I give you a whole lot of space to write down all your answers. But you can bring blank paper if you want more. Okay, so this tells you what the questions are. The extra credit problem, just let you know, this will not be changed. This is exactly the same. So this is something you can do in advance, basically. Okay, and basically what it does is it gives you information on how I can improve the class, and it makes you think about how to improve your own doings. Okay, so that's just a note, is that extra credit problem, don't leave it blank. Okay, it's free points. Okay, and if you don't want to take free points, you're crazy. Okay, all you have to do is write some things in. Okay, you don't have to write 20 paragraphs. Everyone gets the same amount of points if they've written something. If you leave it blank, you don't get points. Okay, and by the way, I give the points. I don't even look at the name when I give the points because I don't want to be biased for one person or another. I don't look at names when I grade. Okay, so this is, again, I'm not going to read every bit of it because this is on Canvas and you can find it. But I want to show you that this is where I recommend starting because this should answer all of the questions that you asked in the chat box. At least I'm pretty sure. I did not give you a set of formula sheets, but this will give you an idea. I'll tell you my secret to doing well on tests when I was a student. And what my secret was I'd write a test. Okay, and you know, that wasn't a professor then. That was when I was an undergraduate student in San Diego. Okay, and what I do is I think about, okay, what kind of problems might be on the test, and then write one, and then I worked with a friend, and then my friend wrote one, I wrote one, and then we took each other's tests. Okay, and you can do that online too. You don't have to do it face-to-face. So if we do work on scratch paper, yeah, you give the proctor the scratch paper, and the scratch paper will scan it in and email it to me. Yeah, so they email everything. They usually even email me the note card, which I don't care about because I don't look at it. The 3x5 note card. If you are going to do something on scratch paper, let's say you're doing number 7 on scratch paper, put a note, let's say we're doing part B on scratch paper, right, C scratch paper. Does that make sense? Because if you don't do that, I may not look at it because I won't know that I'm supposed to look at it. So make sure you guide me to look at the scratch paper. Otherwise, you might not see it. I mean, I might not see it. Okay, any questions at all on this practice midterm, or this midterm shell, I think I'm going to call it. Okay, let me show you some other things. Let's go back. Something that I said I wasn't going to talk about it until I reviewed for the midterm when I did the orientation, where it says review applets. If I click on that, I made an applet that says practice true or false questions. And what you can do is you can click all the things that you might get tested on, which are the first 4. And I did this in JavaScript, so this should work on your smartphone too. You can do this when you're sitting waiting for someone or whatever you do on your smartphone. And then I hit submit. And these are a lot of true falses. There's hundreds of these I wrote. A long time ago I wrote them, but things haven't changed much. And that's a good practice. What I recommend is looking at it. I'll just do this one. If z is a random variable from a standard normal distribution, and if the probability of z is less than a is 0.42, then the probability of z is less than negative a is 0.58. So let's see, what do you think? True or false? Type in chat box. I'll see what the majority says. All right, all of you. Okay, you're all saying true? At least we got 2 trues. So I'm going to click true. And it was true. But don't just say it's true, I'm going to go to the next one. Read, it says since the normal curve is symmetric, probability of z less than a is equal to the probability of z greater than negative a. By the rule of complements, this is the same as 1 minus the probability of z is less than negative a. So make sure you understand why it was true instead of just guessing. Because you got a 50-50 chance of guessing. Just a note, if you leave it blank on a true-false question, what is the probability that you get it right? 0. Okay? If you don't know what the answer is, and you guess, and you don't leave it blank, but you just blindly guess, what is the probability that you get it right? Yeah, 0.5. What is smarter? Yeah, so promise me, don't leave anything blank. I can't give you points if it's left blank on true falses or on anything else, actually. So I can give partial credit if there's anything that has any, tone of being looking okay. I can give you some credit. I never give you negative points on a problem. So you should do your best on thinking about just giving reasonings, even if you don't know how to complete a whole problem. Any questions on that? Okay, here's some suggestions. Okay, today's a bit longer day because we're going over the midterm too. There's a lot to do today. Next week may not be as long, although we do have the project to talk about next week. But next week I might even do a later one. We'll see. Okay, so what we've got here in modules, what you can do is you can go to any of the weeks. So for example, last week, confidence interval. And you should be able to click on the assignments that were due. So for example, you can click on week 6 confidence interval. And look at these examples. Okay, and definitely look at mine. And make sure that you can write this stuff out because the test has a lot of writing. Okay, so I recommend, re-looking at these discussion posts and make sure you can do this kind of writing. Don't assume you could do it a few weeks ago, so now you can still do it. Does that make sense? Okay, so that's one way of studying. Another thing you can do is you can go to an old assignment. So like, oops, not that one. That one won't help. Studying secret word quizzes isn't going to help at all. There it is, this one. So you could also relook at these confidence intervals. It'll be in review mode for you. but you can still look at it. Any questions on that? Good, you've been reworking the homework and that helps. But also rework the discussion posts because that's where all the writing is, and a test has a lot of writing. Yeah, so that's a recommendation, is to revisit the discussion post writing and make sure you can write it all out, especially this week and last week, because that's a lot of writing happened in the problems. So those are some things you can do. I mean, there's a lot you can do to practice. Okay, there's a whole lot. And I think that's it. Let me think. That's about it. I will be, you know, I usually wait until after I get all the midterms back before I grade them. So even if you're taking the midterm, say on this Friday, you're gonna have to wait until next Thursday before you find out your grade, or maybe next Friday. But it takes me time to grade them, and I wait until I have them all. Okay. So in terms of, you know, timeline, that's the timeline. Any questions at all about the midterm? Okay, and by the way, the statistics show, you know, what's the best thing to do just before the midterm, other than going to the bathroom? Sleep just before it? Well, maybe if you're taking it at 8 in the morning, but if you're taking it at 3 in the afternoon, probably not, actually. Yeah, the night before, good, but what about the hour before? Nope. Actually, they found out review is one of the worst things you can do the 1 hour before. You want to do a whole lot of that the day before. Eat is okay if you're hungry, but actually they say what you're supposed to do is a light exercise. Like take a walk. I used to throw a Frisbee around because I was in San Diego. Yep, a little light exercise. Nothing too heavy, but just get your body moving, your circulation going, and that's supposed to help a lot. And I've seen some statistical analyses, you know me, to show that that works. The second best thing they found was meditation, actually. Okay, so I will hang out until there's no more questions. And then I'll go home. Actually, I'm going to ski under the full moon. Should be beautiful. But if you have questions, I can answer them. And I'll also be checking the Q&A form, as always. It is cold. I got lots of bundle up clothes. Do you have a list of the important, can't think of the word, not codes, but totally formulas, you mean? I don't have a list. What I recommend is when you look at the, where is it? The shell. That will give you some, not all, but that will give you some when you practice some problems like these. The chapter 3 ones, there's kind of a bunch in there. You can look in the PowerPoints. They're in there. The PowerPoints are a good way of finding all those formulas. Does that make sense? To re-go through the PowerPoints? And again, when you read this, you'll start getting some. There's 3 sample size formulas, for example, from the last chapter, from chapter 8. This chapter doesn't really, I don't think, has any formulas. But chapter 9. Chapter 7 has a few formulas, sigma over root n, and sigma times root n, and mu times n. Those are formulas that happened. I'm going to say the last 3 weeks. Yeah, the test, because you kind of had a midterm that was online on the beginning stuff. So I do a little less of the beginning stuff. But there is some of the beginning stuff. Don't ignore it. So problem 4, 5, and 6. But definitely it's heavier on the new stuff. The new stuff's more important too in terms of what I'm hoping you get out of this class. Okay, other questions? Any questions? Again, I'll stick around until there's no more questions. Or until there's no one left in the room. All right, and I wish you all success on this midterm. Yeah, Q&A forum is the best way to ask while you're studying. There's also online tutoring that can help too. But Q&A forum will online tutoring is instant, whether I'm there or not. The online tutoring is instant. Q&A forum is doesn't take too long, but you have to wait a little. Okay. Have a good night, Chanel. Any other questions, Taylor? Okay, and for all of you who are watching this as an archive webinar, thanks a lot. And I wish you success on the midterm. I hope everyone does well. And have a good week. Post on the Q&A forum for any questions you might have.